Welcome to the Software Report, a leading information source on software companies and solutions. In this episode, we speak with Ken Claffey, President and CEO of VDURA, a company building data infrastructure for high-performance computing and AI workloads. VDURA's platform is built on the PanFS parallel file system and combines flash-first performance, software-defined services, and a global namespace to support on-premises, cloud, and hybrid environments. The company serves more than 1,000 organizations operating AI pipelines, digital twins, and large-scale scientific and enterprise compute. Claffey joined the company to lead its evolution from a hardware appliance model to a software-first platform, and to align PanFS with emerging AI use cases. He focuses on connecting product strategy, architecture, and customer requirements as organizations scale their compute environments. I'm your host, RJ Lumba. We hope you enjoyed the show. If you liked the episode, click to follow. Ken, great to see you. Thanks for taking the time.
Well, thanks for having me. Pleasure.
I thought we could start at the beginning, meaning this company has been around for quite some time. It was formerly known as a different name, and I believe the technology grew out of, correct me if I'm wrong, Carnegie Mellon. So maybe can you take us to the history, because I believe some of that original technology is still in use today.
Yeah, sure. When I talk about this, I always say to people, it's like every Marvel superhero. That's a good one. The origin story is always really interesting, right? So probably reading too many Wolverine comics back in the day. So the company itself was founded by a gentleman called Dr. Garth Gibson. And Garth is, in our nerdy world of storage, is pretty famous. He co-invented RAID. So, pretty seismic impact on the industry. And then obviously he founded the company, the artist formerly known as PanFS. And his concept was very simple. He really invented the concept of a parallel file system. And his design point was really, hey, I want to create something that is enterprise class. Why do I make that differentiation? Well, it's kind of funny. Numerous parallel file systems, which are so important, and we'll talk more about it, I'm sure, later in the world of AI, and obviously have been super important for the world of HPC for decades now. And we can argue about it. Hopefully you won't argue too much, but let's say there's 3 to 4 parallel file systems in the world today that have been proven to work at scale and stand the test of time. So candidly, one is called Lustre. It's an open source parallel file system. I spent well over a decade of my life working on that. Happy to dive into that in a follow-up question, if you will. And then there's GPFS, also known as Spectrum Scale from IBM. We can argue about some others, but the other one really is PanFS, our parallel file system that Garth created. And, when you look back at the time, this takes you back now really to the early 2000s. I always ask Garth when I took over the company here about 2.5 years ago, I was like, if you could go back in time, Garth, and change one thing, what would you change? Which, as the new CEO, you're talking to the founder, seemed like a pretty reasonable question. The answer kind of surprised me, and maybe it says more about me than it does Garth. The answer I expected, I should probably say, is, I wouldn't have hired this person, or I wouldn't have done this, I wouldn't have focused on this market. And his answer was actually, the mistake I made was, and it's hard to believe now, but I think it's very pertinent to today's conversation, is like, look, Ken, back in the 2000s, no one wanted to fund a storage software company. Everyone was looking for the next network appliance, hardware appliance company, software delivered, hidden underneath the covers in that appliance model. And ergo, when he started the company, his passion and his vision was around software. Ultimately, the company became a hardware appliance company. And, if he looks back now, he says that's probably the biggest mistake he made. He looks at what we're doing now, obviously, as VDURA, and we're a pure play software company. He's like, this is the company I always wanted to have. So, like so many things in life, timing is really important.
Yeah, it's interesting. On this podcast, we talked to different kinds of companies in terms of how they've evolved. And we've seen this before, where it's a company that started out and maybe took some twists and turns and changed the way it approached its marketplace. And, you've also brought in capital along the way. You had different investors that maybe have come in and out of the company. Tell us maybe more so within the last 5 years, because you joined 2.5 years ago, as you mentioned. What was happening at that point, maybe like right before you came in, then you came in, and what your mandate was for the company?
Yeah. So many companies. It's like any relationship. Every relationship goes through different phases, as we've all experienced. I think at the point when I really joined, the investors in particular had seen what was happening with the convergence is probably not the right word, right? You could say the convergence of HPC and AI, but really the consumption of HPC by AI is a far greater market in almost every aspect than HPC. But they saw that and really saw how prevalent parallel file systems were becoming in that AI use cases. And they really saw, hey, we're not really partaking in that opportunity in the way we would like to. And they really wanted to bring in myself and a management team that could really take advantage and really repivot and redirect the company, and frankly, its product core technology architecture and make it far more relevant in that space. And that was really the mandate, and certainly the vision that I had for the company for myself and many of my team members who are now here joined.
And tell us about yourself. We always like to learn about the CEO of the company. You're from Ireland, I believe, and then you've spent, many years, decades in technology.
Yeah, my wife likes to joke, I can't really change a light bulb, but when it comes to storage, I've probably done everything. So, yeah, I grew up in Ireland, worked for an Irish storage company that was called Eurologic. I worked there pretty much straight after doing my, graduate work. So I would have been a 19, 20-year-old young Ken Claffey, and the company was based in Dublin. We were an OEM supplier of storage systems. So hardware, firmware, very little software content, but we were the main supplier to big companies like NetApp, big companies like Dell. Ultimately, that company was acquired by a US-based storage company called Adaptec, which I'm sure many of your listeners will be familiar with. And then, to give a bit of a life experience, I continued to work in Europe for Adaptec for a couple of years. And then the opportunity arose for me to move to the US. So very topical, I guess, with the current political climate. So I moved over to the US, and Adaptec had a number of facilities, but ultimately the facility that I was based out of was in Orlando, Florida. Worked there for a number of years. And then ultimately a company called Zyrotex, that was a UK-based storage company that was a management buyout from IBM, was a public company, offered me a position. And also they had an office coincidentally based in Orlando. So I moved from Adaptec to Zyrotex, spent a lot of time going back and forth across the Atlantic to the UK, racking up a lot of air miles for many years. Ultimately became part of the executive team of Zyrotex. We sold that business to Seagate in about 2017. I guess the piece that's probably for our conversation here also very pertinent is when I was at Zyrotex, I mentioned Lustre earlier. So we actually created the world's first HPC storage appliance based on Lustre. I've listened to some of your other interviews that we probably have different opinions with some of the other people as to how the world came about. But at that time, Sun Microsystems was being acquired by Oracle, this open source parallel file system called Lustre. Its future was kind of up in the air. So at Zyrotex, we bought the copyright, all the intellectual property, trademark. And we also acquired a small company called ClusterStor that was founded by a gentleman called Peter Brown. Peter was the originator of the Lustre parallel file system. And again, we together with the Zyrotex was also a hardware company, had what we'll call firmware, RAID technology, a little bit of software. And we really married that with the Lustre expertise we got through the acquisition of a small company called ClusterStor, created the world's first, again, HPC storage appliance, powered the majority of certainly the top 10 supercomputers and significant portion of the top 100. And I would set the benchmark for actually before we came along, everyone was using their own version of open source Lustre, stitching it together with different pieces of commodity hardware or RAID systems, and ultimately spending many, many months and many, many PhDs to get it to work. And we appliancized it all, and it significantly improved the performance. Before we came along, the fastest system in the world was 250 gigabytes a second. It was housed in Oak Ridge National Labs. It was called Spider. And then just 2 years later, we came along with a system that was housed at NCNA at the University of Urbana, Illinois, and delivered over a terabyte a second. And we did it with 1/4 the amount of hardware. So as you think about software, one thing I always say is like software guys think hardware doesn't matter, and hardware guys think software doesn't matter. And like so many things, somewhere in the middle is the truth. So yeah, it's been an interesting experience. And then when I was at Zyrotex and pioneering the market in the world of HPC, I competed against what was Panasys. knew a lot about their software. I knew that if a customer was using PanFS, even though at the time when I was at Xyretex, our price performance was demonstrably better, the ease of use, the reliability of PanFS, you just couldn't break into those accounts. So I knew the software had something really good, had continued to stayed at Seagate post the acquisition for over 10 years, had kept my eye, frankly, on PanFS. And then when I saw how the world was turning in terms of the interest and need for parallel file systems in AI, I knew PanFS had something that I thought was pretty special, but a lot of things weren't optimized and weren't right. So it was kind of frankly, a bit of a diamond in the rough. And then when I talked about myself and the team who had already, frankly, spent so many years developing the world of HPC storage, we had the right knowledge, experience, and capabilities to really turn it into something.
Mm-hmm. And when you were on the other side, looking at Parnassus, were you thinking, okay, they are the leader in a certain sector or particular capability?
Yeah, like when we looked at specific use cases, so the way we look at it, if you could classify the market, you would have, Department of Energy labs, and they've changed now. So this is the statement looking in the past, but they were far more forgiving for system downtime, poor availability, even data loss. And the concept being, well, Lustre is like a Formula One race car. I remember being told it goes really fast, but it's going to break down a lot, and you're going to need a crew of PhDs to get it fixed. And frankly, our system was based on Lustre when we did Cluster Store, and it had many of the attributes of Lustre of going very fast, but also had many of the failings of Lustre of, hey, it just wasn't designed to be resilient. It wasn't designed to protect your data. And again, we and different people try to make up for that by using legacy HA RAID systems and technology underneath. But fundamentally, it's all about what is your file system capable of. What I'd seen with PanFS and PanFS was where it was much more I would call, industrial HPC or enterprise environments where the customer still required high performance for sure, but placed possibly an equal or greater priority system availability, data integrity, data durability. And that was where PanFS really shone, balancing not just performance, but just ease of use management, and just frankly, customers would say, set it and forget it. It just works. So that was the piece that I knew. And, if you go back, and I'm sure many of your listeners will attest, if something's designed to be one thing and you try and make it into something else, that's very difficult. So if you take something that was designed to be fast, but wasn't designed with resiliency as a key tenet, you can band-aid it, but fundamentally, there's always going to be corner cases and failure scenarios that it just doesn't handle well. So what I knew with PanFS, from having, again, observed its uses and talked to customers, and frankly, tried to convince customers to move away from it, I knew that ease of use, enterprise reliability, and that really goes back to, as I said, that original design point that Garth had. It had those inherent, design principles in its core architecture. And frankly, the areas that it was lacking were areas that I felt would be relatively easy to address, because the limitations was not in the software. It was in all the things in the business that surrounded the software.
Mm-hmm. There's several sectors that you focus on now. Could you give us a sense for which ones are the most prevalent, that VDURA is most well known for in those particular sectors?
Yeah, well, I guess what I would say is we have well over 1,000 customers and systems installed today. So there's very few high performance use cases that we have not been deployed in. So that's probably the first thing. Clearly for us, the new area is related to AI. I think what we're seeing is a lot of what could be classified as traditional HPC customers' use cases are now being infused with AI capability. So you've kind of back to maybe the bigger macro market trend of this kind of convergence of HPC and AI. There's very little use cases now by any vertical that are strictly HPC. There will always some element of AI. And I would say the AI element, in terms of, if we look at the portfolio of applications that these customers are supporting, obviously AI is increasingly growing. So on one hand, you have, as an example, traditional simulation and modeling digital twins that we could broadly classify as HPC. And then you've got increasingly like LLM-based AI use cases. And obviously they're the use cases that are within our customer environment are growing. And that is true whether it's a federal US government kind of application, any of the neo clouds, obviously, but also, more traditional use cases and verticals across academia, biotech, life sciences, and obviously oil and gas as well.
Mm-hmm. We were talking about use cases. I'm wondering if there's some customers that you've had where you've been able to dramatically impact kind of the speed at which they're able to operate their systems.
So, I think it's interesting by different customers have clearly different metrics. Typically, people will talk about gigabytes per second. And then obviously, as we think about AI, you're obviously going to be talking about GPUs, and everyone talks about saturating GPUs. What I'll say is that both AMD and NVIDIA do a really good job of specifying the amount of storage performance required per GPU. What you can clearly see is that if you fail to saturate the GPU and you essentially starve it of IO, particularly where you're going through training and doing checkpointing, that has a demonstrable impact in the ROI. And many customers, when you're deploying these large AI factories, you really do, and having run factories myself, you think about yield and productivity. If you're running a checkpoint every 60 minutes and that checkpoint either fails to complete, and again, for your audience, a checkpoint is essentially where you're creating the compute cluster, taking a snapshot of all the data that's held in volatile memory, and as fast as possible, you're destaging that data from that volatile memory to persistent storage. That is checkpointing. By the way, that has been done and honed in HPC for decades. That is really what parallel file systems have been essentially designed to do, and there's no storage technology that does it better. And what we've seen is we've got specific examples with customers where, unknowns to them, their GPUs, and in many cases, these are mixed environments where they have GPUs and CPUs, but their GPUs were being starved. And not only that, we had a very specific use case where sometimes storage architectures can be very complicated. And what I mean by that is, you've got different type of storage media. And again, having worked at a media company, I can tell you that you think you know a lot about storage when you've done storage systems, RAID systems, and parallel file systems. And then you go work for a company that actually makes the media that stores the stuff, and you realize you don't know as much as you think. So what you kind of look at there is you've got a mix of HDDs and SSDs. And I think there was a pervading view for a few years, not one that I shared, that SSDs are going to take over the world. And now the economic reality is that people projected very wrongly that the price per terabyte of SSDs, flash, and HDDs would converge or get closer in a meaningful way. That's actually the opposite of what's happened. They've diverged even more, which means that if you're building an infrastructure and you're looking to get to petabytes and tens of petabytes, 100 petabytes, and indeed customers that we deal with are in the exabyte range, you really want to use a blend of different type of storage media to get the optimal price performance and price per terabyte. What we saw with one particular customer is they had deployed a particular type of vendor for their all flash. The all flash really where you're getting your maximum performance, that's where your checkpoints are hitting, etc. And then they had a third-party discrete object store on the back end. That was where they were getting all the lower cost, longer term capacity-based storage. And then obviously you had to move the data from the flash to the higher capacity HDD tier. This would prove to be incredibly difficult. And it's not surprising. I think even if you're not a storage expert, you step back and you think about it, okay, you're going to have storage stack A trying to talk to storage stack B with data movers being their own storage stack C in between. Not surprisingly, that doesn't work well. It's not stable. It's not performant. The customer had tried to get it to work stably for a year, just wasn't performing. And we were able to come in to get it around a POC. We're able to prove that we were able to give the customer more than 5x improvement in performance, significantly and demonstrably reduce their footprint in terms of power and space. And obviously, and one of the things, again, back to the core tenets of our technology, we're able to sign up to and meet an SLA in terms of availability and durability. And this particular customer is a mission critical environment. This data centers themselves are in colos, they're remote, they don't have people on site. So the real test of a storage system and data infrastructure, particularly when you operate at scale, and this has been known in HPC as an old adage for years, everything breaks at scale. So it's not about how fast are you, it's about how fast are you when things fail. Because at scale, you're dealing with something failing nearly all the time. And I will tell you that is what we do better than anybody.
Mm-hmm. We're coming up on time. I have two final questions. One is, can you tell us about a person who has had a profound influence on you?
How do you do this and not sound corny? Yeah, I'll probably sound corny, so I'll probably just go back to my parents. So when you asked about my, kind of grew up, my family had various small businesses. Some from a very young age. I mean, like 5 or 6, I was working in a family business. And in the business, we're dealing with a lot of different customers, a lot of organization of different events. So my dad on his side was an accountant. So I learned finances for him. My mom was far more entrepreneurial. So I probably learned a lot more about business creativity ideas and converting ideas into, from concepts into reality from her. So I probably give them both equal credit in helping shape how I approach business.
The last question, can you tell us about a charity, cause, or other endeavor that you're passionate about?
Yeah, so both my kids, and including myself, are dyslexic. So that's something that I've seen a pretty interesting journey of, and even extended to my extended family as well. So I think it's a time where when you have kids yourself and you look at the challenges that many kids have had as a result of COVID, and particularly, frankly, living in California, kids are out of school for a long time. For example, I coach my kids' soccer team. And while I love soccer, a lot of that is just to try and obviously spend time with my own kids, but obviously help the other kids. I just see that the kids today are really struggle with their social skills far more so. And I think, we have to be really careful of isolation. So one of the things that I am certainly very passionate about and spend time volunteering, frankly, in our local school is supporting. And actually, my wife I have to give her huge credit. She's incredibly involved with this, but just advocating for neurodiversity, helping kids and parents identify early, removing the stigma. Roughly about 20% of kids today are dyslexic, but if they can, get help early enough, and help is just being the right level of tools and mechanisms to be able to, frankly, channel their gifts. I think that's something that I'm very, very passionate about and spend a lot of my own personal time on.
Wonderful. Ken, thank you so much again for taking the time. It's been a great conversation.
Thank you. Pleasure.